here I am going to prove this one, sin x by x, or the so-called inner product formula of sin x by x is equal to this much. How it is? To prove this one, sin x by x equal to this much, consider a simple polynomial having highest power is 2, suppose. That means if we are going to consider a in general, a polynomial ax square plus bx plus c equal to 0, having highest power is c, sorry, highest power is your 2, then this polynomial can be written as, how many roots we can get for this polynomial? So it has two roots. So it has two roots. Okay, two roots. So suppose one root is your x1 and another one is your x2. Then the above polynomial can be written, the above, if these are x1 and x2 are two roots, then above polynomial can be written as a into x minus x1 into x minus x2 equal to 0, right? Now consider another polynomial. Consider a polynomial whose highest power is infinite. That is, here I consider a polynomial like this: a naught a1 x plus a2 x square plus a3 x to the power 3 and so on. So this is a polynomial whose highest power is your infinite, right? So hence this polynomial can be written by infinite number of multiplication terms. That means some constant, I'm going to write some constant c into x minus x1 into x minus x2 into x minus x3 up to so on. Because if we consider a polynomial having highest power is 2, so obviously this polynomial has two roots, so this polynomial can be written as like this. Likewise, a polynomial whose highest power is infinite, we can get infinite number of roots. Infinite number of roots. If it is so, then this polynomial can be written as infinite number of products by considering the infinite number of roots. So here x1, x2, x3 up to here x1, x2, x3 up to x infinite are the infinite number of roots. So this polynomial can be represented like this. Now we are going to consider sin x, the expansion of sin x, or the so-called Taylor series of sin x about x equal to 0. It is nothing but like this: plus x to the power 5 by 5 factorial minus x to the power 7 by 7 factorial plus so on. It will be continue up to the power will be infinite, or we can write in general as n equal to 0 to infinity minus 1 to the power n divided by 2n plus 1 into x to the power 2n plus 1. So here you can see, for this polynomial the highest power is infinite, so n is moves from 0 to infinity. So here x to the power 2n plus 1 means x to the power infinite. So this polynomial sin x expansion is also a polynomial. This sin x series expansion is itself a polynomial, yes or no? It is itself a polynomial, and this polynomial has highest power is infinite, or we can say this polynomial has infinite number of roots. Hence, as we discussed previously, hence this sin x can be written as as product of infinite terms. That implies sin x can be written as c into x minus x1 into x minus x2 into x minus x3 up to so on. And here I'm going to write perfectly. Here x1 and x2 up to so on or up to infinite, we can say, are the roots. Here x1, x2, x3 and so on are the roots. Okay. Okay. Now consider this sin x in polynomial format. Polynomial format means sin x equal to 0. That means this one, sin x represented as infinite product or infinite number of terms multiplied with each other. If I am going to write equal to 0, then it will be called as polynomial. Polynomial like this one. Okay. Here this is your polynomial having highest power is 2, and this can be written as product of two terms. Here sin x, this one is a infinite, highest power is a infinite, that means infinite number of roots we can get, and the sin x can be represented by product of infinite terms. If it will equal to 0, then it is nothing but your one polynomial. So if I am going to consider sin x equal to 0, that implies x equal to 0. Okay, plus or minus pi, plus or minus 2 pi, plus or minus 3 pi, and so on. Okay, or I can write in general x is nothing but k pi, where k equal to 0, plus or minus 1, plus or minus 2, plus or minus 3, and so on, and so on. Right. Now that implies sin x will be written as here, this one, or this polynomial, c into x minus x1, x minus x2 up to and so on will be equal to 0. This polynomial, that means sin x equal to c into x minus first root is your 0, so it is x minus 0, then x minus pi, another root is your plus pi. Here this one, here if I'm going to consider this one, then from this I can get plus pi and minus pi. So if I'll be consider plus pi, then it will be x minus pi. If I'll consider minus pi, then it will be x plus pi. Then by considering plus or minus 2, we can get again two roots, that means x minus 2 pi into x plus 2 pi, right? Then x minus 3 pi into x plus 3 pi, and so on, right? Or this can be written as, that implies in summation format, what we can write, that implies sin x will be equal to c, here x minus 0 means x product summation starts from k equal to 1 to infinite x square minus k square pi square. Why I have been written this one? Here you can see x minus pi into x plus pi, this will be x square minus pi square. Here if I will multiply these two terms, it will be x square minus 2 square pi square. By multiplying these two terms, we can find x square minus 3 square k square. So in general, we can write this one, x square minus k square pi square, right? Now that implies here x is there, x taken this side, it will be sin x by x will be equal to c product summation starts from k equal to 1 to infinite whole into x square minus k square pi square, right? But we know that for x tends to 0, sin x by x equal to 1. Okay, now we are going to apply this condition on the above equation. What we can found, first we have to write, that implies limit x tends to 0, sin x by x. Likewise, I have to apply limit x tends to 0 on the right hand side of this equation. What we can found, c limit x tends to 0, product summation k equal to 1 to infinite x square minus k square pi square, right? That implies this value is your 1. 1 is equal to c, and if I will put limit x tends to 0, then here if I will put x equal to 0, then this value will be 0. So we can get product summation k equal to 1 to infinite minus k square pi square. That implies 1 by c will be equal to product summation k equal to 1 to infinite minus k square pi square. That implies c we found here, product summation k equal to 1 to infinite 1 by or minus 1 by k square pi square. So here we found c value, right? Now it will be better that we have to put a equation. Let this is equation number b, and this is your equation number a. This one, sin x by x, is your equation number a. Now we have to put uh, b value, equation number b, that means c value in equation number a. What we can get here, if I will put, then what we can get, sin x by x will be equal to, here both the summations are equal, so I can write summation, product summation is infinite product or product summation. We can say k equal to 1 to infinite minus 1 by k square pi square whole into uh, x square minus k square pi square, right? That implies sin x by x will be equal to product or infinite product that starts from k equal to 1 to infinite. If I'll be multiply this one with this term and this term, we can found here this will be 1 means plus आ जाएगा वो 1, this term will be minus x square by k square pi square, right? k square pi square, right? This is your equation number c. इसको c दे के रखो, शायद हम here you can see. Now here you can see we consider I consider this one, k equal to 1 to infinite, k equal to 1 to infinite. So this will be k square, mistakenly I written this one, this will be k square pi square k square. Okay, so here I have been proved the same, that sin x by x equal to k equal to 1 to infinite 1 minus x square by k square pi square, right?